This is our Unit 3 quiz on similar triangles. In similar triangles, corresponding sides are proportional. It can be helpful to draw triangles so they are facing the same way. And we could set up proportions and then use cross multiplication to solve. Those are just some strategies, right? So let's take a look at this example. If triangle GFH is similar to triangle GIH, which equation is true? So I actually don't mind it drawn this way, but let's just, what I'm gonna do, because I can, is just redraw this triangle. And okay, so this was G, whoops, that is way too big. Wow, I totally forgot what letters there were. Oh, G, F, H. Okay, so we have this set up. GF is to FH. As JI is to JH. Nope. Right? GF is to FH as JI is to IH would be it. So GF is to JH. So this line is to this line as JI is to GH. So that also wouldn't work because if you're doing this triangle and then this triangle, you should also, for the next one, if this triangle is on top, it should stay on top. So let's look at C. And we have HI is to JH as JI is to GH. So that's not going to work either. Then we have GF is to FH as JI is to IH. And that is your answer. Okay, so let's take a look. You don't have to draw it like that. You could have kept the old drawing. And I don't think it would have been that hard to actually see the corresponding parts, but it can help you to draw the question again. I mean, it could help you to draw the triangle facing the same way. So let's move to the next one. The triangles below are similar. Solve for x. Okay, so I'm going to set up a proportion. And I have x, because I like seeing x on top, over 35 is equal to, right, the corresponding parts. Okay, this is a 1 here. Okay, so in other words, let me use this because I'm better with this. X, right, is 235. As this 2142 is to 147. Okay, you could name these. I mean, I'd have no problem naming the sides so that I could see the corresponding sides, right? As long as you are putting the corresponding sides into a proportion. Okay, so I'm actually going to open my calculator, and 2142 times 35, because I'm going to cross multiply, right, is equal to 74,970. Okay, so I cross multiply, and then do this side. Okay, so I have 147x. I'm going to divide both sides by 147. So divide by 147. Okay, and x equals 510. Okay, so to check to see if that works, 510 times 147 should equal this number, right? Should equal 74,970. Yep. Okay. So x is 510. I'm going to erase this. Okay, so here we have a triangle with parallel line, and the diagram DE is parallel to BC. Solve for x and y, so we can use a couple of different ways to find y, right? It's going to correspond to this, which is a whole side of a triangle, not a piece. To find x, x is a piece. There's a couple of different ways we can do this. We can set it up where we're using whole sides, right? But then you have to use an equation with x where you'd have 7 plus x as the length of AB, right? Because AB is 7 plus x. Just like AC is 9 plus 18. Okay, but I feel like to find x, there's an easier way, right? we can set up a proportion and use side splitter theorem, or triangle splitter theorem, right? And we have x over 7, right, is the same or is equal to 18 over 9. So we get 9x, which I actually feel like it would be easier to do, but let's, right, is equal to 7 times 18. The reason I didn't do the multiplication, which you could have just done straight from here, is did 18 divided by 9, right? Because it goes into it easily. And I'm going to just show you by solving the equation. And so this becomes x equals 7 times 2, right? Because this is 9 into 18 is 2, which you would have gotten here. Okay, and so x equals 14. Okay, that's x. Okay, so to find y, you could use the whole side from a to b, but you could also just use a to c. If you couldn't find x and you were like, I'm not sure how to do it, you could use a different side. So remember, we have two triangles here. We have this one small triangle, right? And then we also have this, we have triangle ADE, that's the small one. And then we also have triangle ABC. Okay, so for triangle ADE, we could set up a proportion. Okay, well, I like to actually put my variable on top first. It's just something where I keep track of things that way. You don't have to, right? So y, okay, is to 10. As this is just one way. You don't have to do y over 10. You could do a different one, right? This is, so I have my big side is to my small triangle side, corresponding side. And 18 plus 9 is 27. Okay, so again, this is from the big triangle. So I'm going to use the big triangle on top. 27 is to 9. Okay. Okay, so 9 into 27 is 3 times. 3 times 10 is 30, so y equals 30. And if you're not sure, right, you can check your work. Also, you could notice this is a scale factor of 3. So 9 is the scale factor of 1, and the whole thing is 27. So it was multiplied by 3 to get to 27. Okay, so then we would multiply 10 times 3, which would give us 30. Another way you could have set this up is you could have did y over 27 is the same as 10 over y over 27 is the same as 10 over 9. Okay, and then 27 divided by 3 is 9. So what divided by 3 is 10? 30. Okay. So I'm going to erase this. Okay. Go to the next question. A triangle has side lengths 3, 4, 5. A similar triangle could have side lengths of. Okay, so they should be something where you would multiply each of these numbers by the same scale factor. Okay, so 6, okay, that would be 3 times 2. 4 times 2 is 8, not 7. 5 times 2 is 10. That would not work. So 3 times 3 is 9. Well, then we could do 4 times 3 is 12. That's not going to work. All right, so we have 3 times what gives me 18? 3 times 6 gives me 18, right? 4 times 3, wait, sorry, 4 times 6 gives me 24, and 5 times 6 gives me 30. So our scale factor is 6. So if we had a 3, 4, 5 triangle, okay, that actually should be a right triangle, but I didn't really draw it that well. 3, 4, 5 are similar triangle, right? Got bigger by a scale factor of 6. We would have 18, 24, and 30. So your answer is B. Okay. So question 5. The sides of a triangle measure 7, 2, and 8. The largest side of a similar triangle measures 32. State the length of the shortest side of the triangle. So we have a triangle. Okay, so la la la. So we have this triangle and we have 8 over here, 7 and 2. And in our next triangle, the largest size, I'm not drawing this perfect, but I just need to make a diagram, is 32. Well, 8 times what gives me 32? 8 times 4 gives me 32, so this is a scale factor of 4. Okay, so state the length of the shortest side. This is our shortest side. 2 times 4 is 8. Okay, you could have also set up, right, a proportion to solve, and x over, right, 32 equals 2 over 8. Okay, if I'm going this way, 8 times 4 is 32. 2 times 4 is 8. X equals 8. So the shortest side is 8. Okay. Triangle ABP, sorry, in triangle ABC, point E lies on AB, point D lies on AC, and angle BCA is congruent to DEA. If EA equals 4, DA equals 5, and DC equals 8, find the length of EB. So it tells us BCA is congruent to DEA. Okay, so it looks weird because I'd want this to be parallel, but okay, we have this also congruent, well, to itself, right? You could say reflexive property there, but let's just separate these triangles. I'm gonna actually... I'm not really drawing that well. Let's just say we have A, even if we do E here and D, but I can make E here. There's nothing saying I couldn't flip the triangle. And if you look at it, this isn't a right angle, but this is the hypotenuse, kind of it. Okay, so we know that this angle is angle A. Okay. Okay, and this is B and C. It is really hard to draw on here. Okay, I think that's a little bit better. So we also know that angle E is congruent to angle C. Well, now we know these triangles are similar by the angle triangle similarity theorem. Okay, so if these angles are similar, we could start messing around and set up some proportions. So EA is 4, DA is 5, okay, DC, which is from here to here, that's 8. So AD is 5, AE is 4, okay, and we are looking to find this right here. Okay, so we're looking to find... Well, this whole line is AC and it's 13. So we know that this is 13. And we want to find a piece of this line, but not the whole line, right? Well, there's a couple of different ways we could do it. We could actually find the whole line and then just subtract 4. So let's find the whole line of AB. Okay, so 5 over 4 is equal to something over 13. Okay, so we end up with 13 times 5 is 65 equals 4x. So let's divide that by 4. And you have 16.25 for x. So the whole line should be 16.25. Okay, and you want to find just this piece of the line, right? So you don't need the whole line. So we can do some subtracting. Let's minus 4. And EB, well, it's not x doesn't equal that. Let me fix that, because instead of saying, it's just that I was solving for x, but let's just call that AB so it's not too confusing. All right, AB equals 16.25. And when we subtract 4, we get 12.25, and that should be EB.